Hello everyone. So welcome to another Leetcode question. Today we'll be solving valid parentheses. So let's see what the question is asking. So it says that given a string comprising of these characters, opening brackets and closing brackets, we have to determine if the string is valid or not, right? So how will we say that a string is valid or not? There are two cases that it should adhere to. One is that the open brackets must always be closed by the same type of brackets. So if we have a bracket like this should be closed by its corresponding closing bracket. If we have a bracket like this should be closed by its corresponding bracket like this. And if we have a bracket like this should be closed by its corresponding closing bracket this. Okay? And open brackets must always be closed in the correct order. So if we have a bracket like this and then following that we have this, then this string is not valid, right? If we have a bracket like this and we have this and this, so if we see here, we go from here, this is fine, this is an opening bracket, so this is fine. Then we go here, this is an opening bracket. Then when we come to a closing bracket, the last closing bracket should be the same as this, right? So in this case it is, so we can simply remove this guys, and then we are left with this and this. Then we come to this guy and we see that we have an opening bracket similar to that, and then we can remove this guys and these guys. So what we are left with is an empty string. So in this case we will say that this is a valid parenthesis string. Okay, now let's quickly go through a few examples to understand what a valid parenthesis is. In this case, we have only two brackets, one opening and closing. So this is true. We have this string, an opening bracket, then followed by closing bracket. So we can remove this. Opening bracket and closing bracket. So we can remove this. An opening bracket and closing bracket, which are both similar to each other. We can remove this. And then finally, we are left with an empty string. So this case also, we should return true. In the third example, if we see, we have an opening bracket, but the closing bracket is not the same as its corresponding opening bracket, right? It's not similar. So in this case, we have to return false. Okay. One important thing that we have to look here is that if we have a valid expression, let's say this expression is valid, okay? We can see that it actually in itself, the whole is a valid expression, or it actually consists of multiple valid sub-expressions. In this case, this is a valid sub-expression and this is a valid sub-expression. The entire expression is given to us to be valid. Okay. So there are two cases that we have discussed, that it could be itself one big valid expression, or it will be multiple valid sub-expression, like we see here, right? In this case, we have two multiple valid sub-expression here. So if we remove all these valid sub-expressions, then we are left with an empty string, and that is the condition to tell that if the valid parenthesis string or the string containing parenthesis is valid or not. As we can clearly identify that this actually holds a recursive structure, right? This has a recursive structure in it, right? So if we go above, we can see that we can first remove this guy, or we can remove this guy. So we are left with this and this, this and this. Then we can remove these guys, and then we can remove this guy, right? Then we are left with only this. Then first we can remove this guy, and then we can remove these guys. And finally, we are left with just an empty string, right? So in this case, we will return it to be true. Let's see a solution using stack to how we can solve this problem. I've already gone ahead and created a map where we have a closing bracket and its opening correspondence, closing bracket and its opening correspondence, closing bracket and its corresponding opening bracket. Now, let's say this is the string given to us. We are currently here, right? So since this is an opening bracket, we can simply take this string and we'll put it into the stack. Okay. Again, when we come here, we see that this is an opening bracket. So we can simply push it to the stack. Again, when we come here, we see that this is an opening bracket. We can simply push it to the stack. Now, when we come here, we see that this is a closing bracket, right? See, this is a closing bracket. So we simply check on the top of the stack whether it's a opening bracket and it's of the same type or not. If it's of the same type, we can remove it from the stack and move forward, right? Now we have an opening bracket. We will push it onto the stack. Now we come here and we have a closing bracket. We check at the top of stack. If it is an opening bracket of the same type, we will remove it and then we'll move forward. Now we have an closing bracket of this type. So we check if in the top of the stack, we have an opening bracket of the same type or not. We have, right? So we can remove this guy and move forward. Now we are here. This is an opening, this is a closing bracket. Sorry, this is a closing bracket. See, so we see at the top of the stack, if we have an opening bracket of the same type or not, then we remove this and then we move forward. This is an opening bracket. So we simply push it at the top of the stack. Again, we go forward and we see that this is an opening bracket. So we push it onto the top of the stack. Again, we move forward and we see that this is a closing bracket. And at the top of the stack, do we have its corresponding opening bracket? We have, right? So this and this belong to the same category. So we can remove this guy. Then we'll move forward and we'll see that this is a closing bracket and we see in the top of the stack, we have this. So is it the same? Yes, it is, right? So we can remove this guy. And we have gone through all the brackets in our string. We'll come out of the loop. And now we have to check if a stack is empty or not. Since our stack is empty, so we can say that this is a valid expression. So what will return? Will return true. Okay, so in this case, we'll return true. The property that stack has to be empty is very important because if we have only opening brackets, we will keep pushing onto the top of the stack. We'll keep pushing onto the top of the stack. And later on, when we come out of the loop, we have to make sure that our stack is empty. So in this case, what will our answer be? Our answer should be false. Okay. Now so one thing that comes into mind is that why are we using stack, right? A stack has some sort of recursive structure in it. The other thing is that while we are going from left to right, we keep pushing it, or we can say that we are holding the information of these parentheses in our stack while we solve the inner sub-expression, right? What does it mean by solving inner sub-expression? It means that this expression needs to be solved first, but we'll need to hold this information somewhere, right? We need to hold this information somewhere. That's why we are using a stack here. We push it onto the stack and later on we'll consume it as we move from outer to inner, and we are done with the inner. We'll try to solve the outward expression with the information at the top of the stack. So that's why we are using a stack here. Okay. Now let's see the time complexity and the space complexity of this problem. So as we are going through each character of the string or each bracket in the string, so if the length of the string is n, then we went through entire characters in the string, so the time complexity will be linear. The space complexity is actually quite interesting here. The space complexity is also equal to the length of the string. Why so? For example, if we have only a string which comprises of only opening brackets, then at certain point of time, what could happen is in our stack, we'll have only the opening parenthesis, right? So our stack could grow linear to the size of the string. That's why in our program, we created an auxiliary space linear to the string in worst case, right? There is some additional info I wanted to provide for this question is that, let's say, what will happen if we have only one type of bracket, right? So in this case, we have only this bracket. So I wanted to ask you if we need a stack for this or not, right? In this case, if you see properly, we don't need a stack. Why? We can simply maintain a count. We can simply maintain a count of opening parentheses, And whenever we see a closing parenthesis, we'll just reduce this count. Whenever we see a closing parenthesis, we'll reduce this count. Whenever we see an opening parenthesis, we will increase this count. Okay. At any time, if this count is 0, anytime if this count is 0 and we see a closing bracket, which means that there is no opening bracket to consume this closing bracket. So in this case, we have to return false and the string is not valid. It is invalid. Or if we come out of the loop, or we have gone through the entire characters of the string and we see that this count of opening parenthesis is not 0, that means there are some opening brackets which were not consumed by the corresponding closing brackets. So in this case also we have to return false. Okay. So in this case, the time complexity will be big O of n and the space complexity will be constant because we have just created one variable and no auxiliary space in between. Now let's just go through the code walkthrough for this. This is actually quite simple. So as we told that we have created a map between the closing brackets and the corresponding opening bracket. And then let's discuss the interface for this function. The interface is that we have to return a boolean and we are given a string. The first thing that we did is we created a stack and we have a map like this. We go through each character in our string and we see if that character is there in our map or not. If it is there in the map, it means that it is a closing bracket, right? So now we get the top of the stack, that what's there in the stack. If the stack is empty, then we can simply put any symbol other than the opening brackets that's there as values in the map. So it would be, let's take X for example here. Otherwise, we will just peek at the top of the stack and get that value. Now, if the value at the top of the stack is not equal to the matching bracket, that we have just encountered as the current character in a string, then in that case we have to return false, right? This we discussed already. Otherwise, if it is equal to that matching bracket, then we need to pop that element. Basically pop that opening bracket from the stack, right? If it is not a closing bracket, it means that it is an opening bracket, and then we can simply push it at the top of the stack, right? This we already discussed. So if we have a string like this, we have an opening parenthesis, so we'll push it at the top of the stack. We have an opening parenthesis, we'll put opening bracket, we will push it at the top of the stack. We encounter a closing bracket, we check in the map. If the top of the stack is similar to this, it is, so we'll pop it, and then we come here. This is in a closing bracket. In our map, we check what's opening corresponding will be. It will be this, and we see that the top of the stack is the same, so we pop from the stack. And then finally, once we are done through all the characters of the string, we just have to check whether a stack is empty or not. If it is empty, that means we return true. If it is not empty, then in that case we return false. So this concludes our fifth problem, valid parentheses. Thank you.